Okay, hello. In the last video, we confirmed that this battery charger is no longer outputting the rated output current. It thinks it's putting out 5 amps, but it's actually only putting out 2.5. The original complaint was that the voltage was off. It is off by about 5 volts. However, that could be related to the output current being messed up, since the capacitor board also does filtering, and if that filtering is not there, then you end up with voltage spikes, which can make it think that it's seeing a higher voltage than it really is. So we're going to investigate that. Very first thing we ought to do before working with any high voltage electronics is discharge any remaining voltage that might be on that capacitor board. And I do that using this is a 7 watt 1.8K resistor, and just kind of cram it inside there so that it touches both terminals, and then you just let it set for a little bit and it'll drain it down pretty quick. And then after you do that, you always want to confirm that it is completely discharged, and it is. You can go to a lower scale. Yep, completely discharged. It also sat overnight, so that helps too. Alright, the first thing we're going to do is we need to take this fan off. I've already unplugged all the connectors, cables, and everything else. And there are 4 screws right here which hold the fan in. Another thing that I always do is I have these little servo boxes, and those become parts bins for everything related to this project, or this repair will go in there, so that at the end I know that I got everything that was supposed to be, or that originally came off the charger, back in the charger. I'm going to switch to a larger bit. There we go. So this will probably be a very boring video until we get inside, so might have to edit that out. After that, you get to the fan here. You'll see a connector inside there. That has to come out, so we're going to cut this little zip tie very carefully. Go. We're going to pull that off, and then we're going to remove this cable here, and they're on there really good. And before I take that out, I'm going to take a picture so that I know that the white wire went to the red and the brown wire went to black. So when I put this back together, we don't get that backwards. So now the fan is removed. Let's set that aside. We know that was working because it was spinning before. The next thing we need to do is take out all these screws. There's a whole bunch of them all the way around the whole perimeter. And so, oh, that one's already loose. Yeah, I guess this is going to be pretty boring for anybody watching. Screws being removed, but you can edit that out, I guess. Now these screws that are stuck down here in the heatsink, oh, that's weird. That one's missing. They're kind of hard to get out. I have a little, you got one of those magnet on extension tools, you can get them out pretty easily. But I don't have one of those, so I cheat and just take a random screwdriver and attach a magnet to it. Use it to get the screws out. So, like so. Didn't get that one. Oh, I failed completely on that whole side. Did everybody? Nope, one more. Stubborn. Okay. I think that's everybody. Yep. Now, before taking the cover off, there's one final thing that is, you need to take this guy out because it's harder to get to later on. I don't remember what size that is. So this battery charger, being made in Germany, is actually all metric. So I have a set of metric nut drivers here. There you go. The interesting thing is, this is the thread's metric. This is metric, but then the inside's 440 standard. So I'm not quite sure how that works. And they've obviously been cut off of something. So I don't know where you get replacements of those. I actually do need some of these. We'll go ahead and take both of those out. And now we're ready to open it. Now the easiest way is to flip it over. There's one wire inside, the ground lead, that, that's nice, a bug fell out. We're going to put it down like this, and I'll move my awesome holder over here, which is a piece of plywood. We're going to take the cover off. Now down inside here, in the corner, there is a ground wire that you want to unplug. Once you've got that done, then you kind of have to wiggle. It's a pretty tight fit. There's a bunch of wires that get caught. And see the wire that is caught. There we go. Okay. Oh, and you're greeted with the wonderful smell of burnt electronics. Let's see if I get this better in the frame here. There we go. Actually, get rid of this. Get a little closer. So here's what we've got. The cable that was getting stuck was this wire right here. It always gets stuck on this cable. When I put these back together, I usually put a piece of electrical tape just to hold it in. But oh yeah, it's definitely has the burnt electronics smell. Yeah, something's definitely been going wrong with it. So yeah, quick overview here. This is the I/O board. This is where all of the connector inputs and voltage sense and communications, everything happens on this board. It also has the high voltage power supply. This board is the processor board. It is very similar to the ones that they use in the AMC 320 and 325 motor controllers. This board in here is the output filter board, and this inductor is the output filter for it, and then all these down in there are the bulk caps for that. And then on this side we have the this is common mode chokes for the input. We got fuses, input filter. If I turn it sideways here, see this board running down the side here. So power comes in through this connector. Oops, hold on, can't see. There you go. Power comes in through this connector, goes up and through here, comes in through here, goes through the fuses. This is all common mode choke. Comes over here to this board. This is the bridge rectifier. Bridge rectifier is actually down here, so it travels all the way down and then back up into the capacitor board, which is this middle one here. Then underneath, well, inside there's the gate driver board. You can kind of see this is the edge of it. That runs all these MOSFETs, and then these are all the different resonant converter switches, and then we've got the diodes on the other side. Let me go back to here. This side's the diodes. Everything comes on the output through these standoffs that are down in there, and then after that we go back out to this filter, then the well, this is just a big inductor on the output filter, and eventually we get out through this fuse, out the cable to the battery pack. So there's your quick overview. So I guess we should start taking this thing apart, and we're going to need 5.5 millimeter socket here. Here I go like that so you can see. So you're going to take these guys out. So there's 1, 2, 3, 4, 5, 6 of these that hold it. Hold this board in. This is the I/O board. Well, I call it the I/O board, analog board. So that one was missing a washer. The other thing I need to undo is this connector right here. Can't see. Back over here. Let's come out farther. It does. Should take a picture of my wonderful plywood holder here. So yeah, you got to take out these ones, but before I do that, I'll take another picture because these two wires here, we got to make sure we get them back right, otherwise won't work. So I'll go ahead and take these out. And then, pair of pliers. There's these little metal clips that you need to take out. that hold the IDC cables on. There's one on each side here. And once you have that, you can unplug those. And then the two jacks that were on that we took off at the beginning, that's down in here. Now this board, even though it's now loose, everything's disconnected, it is actually socketed. The processor board socketed into it through the header down there. Unfortunately, there's no way to undo that simultaneously, so you kind of have to come in here and push on it, and you can see that connector went into there, and now you have the I/O board. You'll have to also loosen this little glands waterproof connector there and pull that out. And then this was our connection that went over to the fan earlier. And there you go. This is the I/O board. This whole section here is your high voltage power supply. High voltage that's been bridge rectified, comes off of that bridge rectifier that was on the other side of the board. That's what they run. That's what this cable here is. It plugs into the other side here. You can see here. So see this cable goes in here. It taps off of the bridge rectifier. So that'll be either your bridge rectified 120 or 240 volts. Comes in here, goes through this fuse, goes through this main power supply, and that eventually gets, it's got a little flyback converter, and this is the transistor. It switches it, and then it regulates to 5 volts, and that's it. This is your giant 5 volt supply to run everything. And yeah, that's about it. Oh, the voltage sense. The original problem with this is the voltage sense is off. This whole section in here is the voltage sense. So it's all these components in here. But we're not going to worry about that yet. We got to go fix the capacitor board first, and we'll put it back together. Because this board's easy to get to. It's right on the end. It's the first one. We'll put that all back together, and then after we fix that, then we'll put this back on and fire it up again, put it on and test it out. And I would not be surprised if it starts reading the correct voltage after that, just from previous experience with these. So we're going to go ahead and set that aside. And you might notice I have no ESD stuff on here. I am in my basement, and the humidity is always pretty high, so you can't generate any static. It just doesn't happen. And the table's nice and moist, so that's my ESD protection. For those that would comment about that. This is actually a smaller 5mm. So I'm going to go ahead and take this out. This will get the processor out. So here's the processor board. Siemens microcontroller. These actually have onboard flash, but for some reason they go with external PROMs. But it is very similar to the one that's in the AMC320 drives. I was going to see, I'm looking over to see if I've got one floating around. Ooh, wait, yeah, hold on. Well, it's kind of hard to tell, but look familiar? It just doesn't have PROMs in it. But this is the one from an AMC325. Very similar. They're not exactly the same, but they're very similar. We're going to go ahead and set that aside because we know that's working at least. Let's see what's next. So this German engineering, they really like to stack boards on top of boards on top of boards. So we got to take this board out next to get to this stack so it can work our way down to get to the cap board. I got to take a few parts off over here. So first thing we want to do is undo the main cables here and see if I can find, is that the right size? Ooh, that is, but my nut driver, what is this? Normally, if you're troubleshooting, you'd be checking all these fuses and make sure everything's good. The fact that it was running before tells me that they're all good, but just for why are you not beeping anymore? Huh. I officially consider this, I bet the battery's going dead in that one. Let me grab another one. There we go. Yep, good thing, high quality tools here. So that fuse is good. That fuse is good. The big one down here is good. Okay, next we've got these off now. We're gonna go, I'll go ahead and close this. Actually, we'll use this other one here. This happens to be exactly the right size to do this. That looks pretty cool. Okay, so let me line that up. See these little tiny guys down in here? This is why you need a nut driver that's like this. Otherwise, these are impossible to unscrew with any other method. Now, unfortunately, my little magnet trick does not work with these ones because they are actually brass. They're tinned brass, and they actually use them, the standoffs, to transmit power between the boards. So I come in here and grab, that's why I flipped it up on the side like this, because it just makes it easier to get everything out. And if you're not too careful, they can go underneath. I think that's everybody. And we've got another one over here. And one more over here. Okay, there's everybody. And then this guy should just slide right off. There you go. This is that main output filter. So this is essentially all of your bulk capacitance and the output filter inductor. Voila. So go ahead and set that one aside too. Actually, before we set it aside, we should examine. Sometimes you might have some of these, yeah, like this one. Well, doesn't look too bad. Does that focus on that? See how some of the vias here around where the pin comes through, sometimes they didn't get them soldered very well, and they'll end up looking kind of bad. So what I usually do is go in there and get out the old soldering iron and touch all the joints up just to make sure that they're good. That one doesn't look too bad. I've seen some pretty bad ones though. So go ahead and place that. Now you can see the these are all the bridge rectifiers, or not bridge rectifiers, these are all diodes that are in a bridge rectifier configuration for the output of the two transformers which are underneath here. And these are the two FETs that actually run the output. So next I gotta take this board off, and this kind of has an order of operations to it. We gotta get, it's not the right one. Where did it go? There it is. So we need to unscrew these, and we need to unscrew this. So we'll do this one first. So take another picture here. And over here. Oh, there's a zip tie on there. I don't know what that's for. Oh, I bet that's supposed to hold this cable in, and then it slipped down. God, that one's on there really good. Alright, bigger screwdriver. Oh man, that one is really stuck. I don't want to strip it. Ah, there we go. Good, 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 good. Whew. I don't know. It'd be a hard part to replace too. Okay. Go ahead and take these guys off next. Okay, this will slide that cable out. That was providing power from the bridge rectifier over to the main power supply. And then there's another little screw in here, or bolt. I believe it is smaller than that. 7mm. Okay, now we can take this guy off. You don't want to pull up, you want to pull straight out because it has a little pin header on there that supplies a voltage over to the monitor, so it knows if you're plugged in 120 volts or 240 volts. Yeah, I bet this is supposed to keep that from getting hooked on there, but it didn't. So go ahead and set that aside. Now that we've got everything done on that, we can finally pull this board off. So we got another 5 screws here, or bolts, machine screws, hex bolts. Back in the center. The annoying noise is the sump pump, if that actually shows up on the video. We're conveniently located near the sump pump. Probably the worst place, but oh well. Didn't have taken videos in mind when I set this all up. So on this board, you want to lift straight up. You don't want to move it because you can see these two little pins right there. That's a pin header. So straight up. You can see very, very hard to get those back in there. Can you see? Kinda, not really. Oh, wait, there, yeah. Two little pins sticking out there. So, yeah. Be careful with that one. So again, we're going to examine this. Yeah, remember like I was saying about sometimes they don't solder them very good. So look at this. Let's see what I got for a pointer. Here we go. See, look at this one right here. Oh, wait, hold on. Where am I at? There you go. Focus. Focus. You can do it.